Good afternoon, everyone. Welcome to attending the session CICD Pipeline and Delivery of Apache Spark Applications on the Cloud using AWS. My name is Maria Fung, and I'm working for the California State University at the Office of the Chancellor as a Data Warehouse Development Lead. I consider myself as a lifelong learner with a passion for technology. For the past 20 years, I'm specializing in data warehousing and business intelligence solutions. When I first started at CSU 5 years ago, we are using Oracle OBIEE product suite, which is a traditional data warehousing tool using star schema, which data is stored in a hierarchical structure with files and folders. For the past 2 years, CSU has been migrating to a data lake model, which totally changed the way we are doing things. With a new role as a DataOps admin engineer, we have selected AWS to implement the data lake architecture on the cloud and the CI/CD process using AWS components. In this session, we would like to show you how we use the AWS resource to support our software development lifecycle. From here, I would also like to introduce Babu Repaka, which is also one of my team members in this project, to introduce himself.
Thank you, Maria. Hello, everyone. My name is Babu Repaka, and I am working for California State University at the Chancellor's office as a business intelligence solution architect. I am an innovative software engineer with 20 plus years of experience. I have been managing all aspects of infrastructure and development for small to big sized companies using my vast experience in ERP and business intelligence technologies. I began my journey at CSU 7 years ago and started off by implementing OBAA Oracle products for our source environments, PeopleSoft, Finance, and HCM in our data warehouse. We implemented traditional data warehouse standards in OBAA with the star schema models. From the last 2 years at CSU, we have been migrating data lake models in AWS Cloud. Presently, there are new technology tools that we use for cloud implementation. In AWS, to create the data lake on the cloud, we used AWS components to implement the DevOps and CI/CD process. Let us show you the details of how and what we implemented over the last year in the cloud for DevOps and DataOps technologies. Now Maria is going to take us forward and present some qualities of CSU.
As many of you in California are familiar with California State University, CSU. CSU is the largest and most diverse higher educational system in the US. We have 23 campuses in California with 50,000 employees employed, including faculty, staff member, and also campus workers. Nearly 500,000 students enrolled this year. CSU has awarded nearly half of the state bachelor degree. 1 in 10 employed graduates comes from CSU, representing 1 in 20 college degree holders nationwide. We produce in the neighborhood of 120,000 graduates per year, and our more than 3.4 million living alumni are employed in every field across the world.
Over the past decade, there has been tremendous change and advancement in how applications are built and deployed by developers as a result of the ever-increasing demands from campus users. In the past, enterprise release cycles lasted up to a quarter, sometimes even longer. However, our application development moves at a much faster pace today. Applications are deployed within minimal amount of time and delivered directly to the cloud. Cloud-based computing allows development teams to build innovative and disruptive data models and disseminate them to thousands of users without having to worry about infrastructure. This is one of the main reasons we implemented agile methodology and have been so successful in CSU Data Lake team. These teams can get real-time feedback from their campus users, rapidly make changes to their designs and features, and ship them updated versions back to campus users, all within a short amount of time. Past, we faced many challenges such as rapidly changing competitive landscapes, evolving security requirements, and performance scalability. Now, we have proudly bridged the gap between operations stability and the rapid future development. Continuous integration and continuous delivery is a practice that enables rapid code changes while maintaining the system stability and security. With DevOps principles, we evolved and improved products at a faster pace than traditional software development and infrastructure management process. This speed enables us to better serve our campus users more effectively in the development process. Our highest priority is to satisfy the campus users through the early and continuous delivery of valuable analytical insights in minutes. We believe the primary measure of data analytic performance is the degree of which insightful analytics are delivered with accurate data. Our three components of data lake management are data integration, data governance, and data security. Now let me show you the details about CICD and components that we used at CSU. Continuous integration and continuous delivery is one of the most important and desired processes for our CSU modern code development and delivering environments in AWS. CICD provides shorter compilation and faster release cycles with more automation and testing. The continuous workflow in the DevOps process is an automated and iterative process from development to delivery in all environments. We used various development, delivery, and platform tools and processing during workflow automation. The continuous process shortens the lead time for application development and deployment while accelerating the releases. We used the following components for CI/CD and DataOps processes. Generally, we used S3 for object storage in data lake in different formats like CSV, JSON, and Parquet, etc. We used code commit for Git-based repositories. Code build is a fully managed continuous integration service that compiles source code, run tests, and produce software packages that are ready to deploy. Code pipeline automates your software release process, allowing you to rapidly release new features to your users. You can use the console to view the history of each execution in a pipeline, including status, source revisions, and timing details. When you create a stack in CloudFormation, it makes underlying service calls to AWS to provision and configure your resources. It is an easy way to model a collection of related AWS and third-party resources. CloudWatch. You can monitor AWS resources such as EC2, DynamoDB, RDS, as well as custom metrics generated by your applications and services, and any log files your application can generate. EMR, Amazon Elastic Map Reducer, is a web services tool for big data processing and analysis. When you process data in EMR, the input is data stored as files in your chosen underlying file system such as Amazon S3. Lambda is a serverless computing service that lets you run code without provisioning or managing servers. It is a combination of Lambda functions, event sources, and other resources that work together to perform tasks. Simple Notification Service is a managed service that provides message delivery from publishers to subscribers. SNS enables you to send messages or notifications directly to users. SQS, Simple Queue Service, is a distributed message queuing system.
Thanks, Babu, for the introduction of our data lake project and the CI/CD components we are using to implement this solution. Now, let me walk you through our current process and show you which CI/CD components we're using in each stage of this process. In general, the process contains two major pipelines. The first one is the development integration testing. The development pipeline starts when a developer checks in his or her code to Git, which in our case, using code commit. Developer will create a pull request to merge the changes to a QA branch and resolve any conflicts. Automation for this process is using CloudWatch rules and alarms to monitor the code commit event, to send an email to the team for peer review. The pull request will be approved by anyone in the team other than the developer itself. Once the pull request is approved, the pipeline will automatically start code build, which the testing will take place. We're using an Amazon Linux container for the build and install PyTest and code coverage for unit testing, as more of our code is written in Python. If all tests are passed and comply with the policy, the build process will package all dependencies and submit a Spark EMR step to the EMR cluster for integration testing. When integration testing passed and completed, all artifacts will be copied to an S3 bucket for later production deployment. We'll cover this process in more details in the development pipeline section. The second pipeline is for production deployment. The production deployment starts when the code is ready to move to production. At this stage, all the code has been tested in the development pipeline and pulled from the QA branch to the master. Like the development pipeline, the CD also uses the CloudWatch rules and event to orchestrate this process. AWS code pipeline is primarily used in this process, and the details will be covered in the production deployment section. Before we talk about the details for each pipeline, security is one of the important factors in the CI/CD process. We have incorporated security measures in different stages of the CI/CD cycle, from development, building, packaging, testing, deployment, and all the way to operation. Let's go through some of the checklists we have used and implemented. MFA, multi-factor authentication, is used for all user accounts to log on to the AWS. Role assignment and segregation of duties are clearly defined. Each user is given only the permission required to fulfill the job duties. Test case and acceptable outcomes are defined to ensure test results meet the company's policy. Secure code repository. Code commit repository are automatically encrypted at rest. The authentication is through IAM role and robust locking and tracking. We also need a secure build and package environment, which repository data in transit is encrypted, and all communications between code build and its downstream dependency is protected using TLS connections. Build artifacts and test report data are encrypted using customer managed keys. Sensitive information such as S3 access key, database logon credential, etc. are stored in Secret Manager, and use of parameter store to retrieve environment setting. We also hold weekly security assessment review meeting using Trust Advisor, Inspector, and Gap Duty. Our weekly security assessment meeting is focused on two major areas. One is management and governance. Trust Advisor is being used to review the following: to see if we have any cost problem, performance issue, security, risk, fault tolerance, and any service limit which is overuse. Any exception raised by the tool will be investigated and addressed right away. The second area is security, identity, and compliance. In this area, we use guard duty to detect any threat for malicious activity and unauthorized behavior to protect our AWS accounts, workloads, and data stored in S3. Detailed finding report is analyzed to resolve any threat behavior. For inspector, we use it to analyze the behavior of the AWS resource and helps to identify any potential security issues. Assessment run is scheduled to run weekly, and the assessment report is reviewed in the weekly security meeting. Any issue will be addressed, like in that meeting.
CICD development process. For development CICD pipeline, we implemented these steps. Developer A will create or update the code in its local Git repository, and once the code is finalized, the code is pushed to the cloud Git repository in its respective branch. Then he creates a pull request for changes from developer branch to dev branch in AWS code commit and a request for approval. Then developer B will verify the pull request and resolve if any conflicts on the code, and he will confirm the code and merge the code to developer branch. Once the merge process is completed and update the comments on files, the CloudWatch will trigger the code build processes. In this automation, CloudWatch will initiate 3 code build processes, which are code build for PyTest, code build for code coverage, code build for EMR. Once these 3 processes are complete, then it will merge to development branch successfully. Then it will send the logs and output files to S3. Now we are going to go to details of PyTest and code coverage development process. PyTest is a testing framework which allows us to write test codes using Python. We wrote the code to test the EMR connectivity and API. We verified the technical and business functionality during this process and validate the EMR and S3 objects. Some of the things verified in PyTest are detailed info on failed assert statements, auto discovery of test modules and functions, can run unit tests, and to measure what percentage of code has been exercised by a test suite. Then when it comes to code coverage benefits, generally quality assurance and testing are costly processes. To avoid that cost, code coverage analysis helps allocate testing resources where testing is absolutely necessary, saving you time and effort, and also offers other benefits such as increased product quality, enhanced user satisfaction, simplified QA process, and compliance audits. During this development process, the developer will get email notification with PyTest and code coverage results. EMR code build process for development pipeline. We also created an EMR development server with CloudFormation every day at 7 a.m. and terminate it at 10 a.m. to reduce the AWS cost. We automated the report submission process for developers and built the automation with AWS components. When a developer checks in and submits the report request for data processing, we will use JSON file in Git, create a pull request, and merge to development folder. The CloudWatch will then trigger the code build to submit the request to EMR server. Once the EMR steps are completed, it will generate the Parquet files in S3. This is the EMR report submission automation flow. The development pipeline is complete with code coverage, PyTest, EMR report submission. Now Maria will continue with the production pipeline details.
The production deployment process starts when the code is ready to move to production. In this stage, all code has been tested in the development pipeline. Configurations and all dependencies are ready to migrate to production. In this stage, the team is focused on documentation and communications. DataOps team will inform the admin team to create a pull request to merge the change from QA to master branch. Managers will be informed and notified to approve pull requests. Like the development pipeline, the continuous delivery process will use Lambda function, CloudWatch rules, and events to orchestrate this process. When the request is approved by management, the following will be automatically triggered. The pull request will be comment and merge to master branch. Build all dependencies and packaging all files to an S3 bucket on the production account. When a change is merged to the master branch, the code pipeline will trigger to deploy a CloudFormation stack. This stack will provision an EMR cluster and run EMR steps in the production account. The deployment process involves using multiple AWS accounts. Cross-account security is implemented using STS assume role, KMS key, in the code pipeline role, and cross-account role from the production account. The deployment process finishes when all EMR steps are completed, and the EMR cluster will automatically terminate it. This deployment process can support continuous delivery in a multi-account setup, and it can be easily recreated for different environments. During the past 2 years of implementing this solution, we have encountered different types of challenges, and we have overcome one after another. What we have learned is ongoing learning. Exploring different ways of doing things is a must. Most of the time, we need to gain more knowledge and understanding of multiple AWS resources and security usage to implement just a single use case. Some of the existing challenges still need to be addressed in the next steps. For example, like lack of job orchestration in the EMR cluster. Workflow is currently implemented using CloudFormation template to manage job dependencies. Another challenge is code pipeline cross-account roles are not transparent on the AWS console. To work around this issue, CloudFormation template and AWS CLI command is the only way to create and make changes for cross-account code pipeline. Our next step, we would like to explore better orchestration by using AWS step functions, or Apache Health Airflow for scheduling, jobs, and workflow management. Thank you for watching and attending this session. If you have any question, feel free to email us or contact us through LinkedIn. Thank you.
Thank you for watching and attending the session. If you have any question, feel free to email us and contact us through LinkedIn.